Welcome back. In this video, we're talking about the dining philosophers. The dining philosophers is a common problem in computer science. It's an example or an illustration of a very common thing in computers. So here we've got 5 philosophers sitting around a table for food. There is 1 fork between each pair of philosophers. So we've got 5 forks, 5 philosophers. And each philosopher has endless hunger and endless food. So let's say there is a lot of food on the table and they are extremely hungry. But in order to begin eating, one philosopher must have 2 forks, 1 for each hand. So as you can see, there are not enough forks for everybody to go round. So how would the philosophers tackle their problem without talking to one another? Well, obviously there is a problem, which is if each one of them picks up 1 fork. If each one picks up their left fork, say, or in this case their right fork, they then are going to wait. Then they're going to pick up the right fork and wait, and they're going to eat, put the right fork down, then put the left fork down, and then start again. But if everybody picks up their right fork, and then they're going to wait for the left fork to become available, they could be waiting for a long time, because every philosopher is also waiting for the other fork to become available. None of them releases their fork, so they all end up starving, waiting for the other fork to become available. So if the solution involves waiting for the fork to become available, they could potentially starve. So we don't want that. The problem is that if all the philosophers pick up their forks simultaneously, nobody can pick up the other fork. So they keep waiting indefinitely and they end up starving. Similarly, if any of the philosophers does manage to start eating, somehow taking up 2 forks, they may never stop eating. And so the other philosophers are forever without 2 forks, and now they've got to share 2 forks amongst 4 philosophers. That's even worse. 3 forks amongst 4 philosophers. So what can you do to solve this problem? There are many ways to solve the problem, and these are normally covered in concurrency courses, computer science degrees, so on. Not going to get into too much depth,